Hey everyone, happy Thanksgiving. We're back from DevConnect and we have more news for everyone. So today we're going to walk you through two features. One is the native delegation and showing how the native delegation can be done on mainnet and testnet. Right, so that's one thing. The biggest thing is the RST. RST stands for Restaking Staking Tokens. So the K2 will enable anyone to have their own staking tokens out of the box, and you can start experiment all kind of stuff, all the tokenomics. You can go for partial decentralization to a full decentralization in a staged manner. You can operate your canary network like other blockchains have done. But this is not just limited to L1 or L2s, but you can actually use these tokens for any protocols, right? Anything that you want to test it out. It could be used for protocols, it could be used for DAOs, it could be used for the votings, governance, any kind of schemes that you want to do it, but it is just tethered to the SPP. So you open an SPP when you're in K2. It stands for stake borrow position. You go for a million ETH backed SPP will be open for you. That's a restake position, but you don't pay million ETH, but you just pay only the usage fee, maybe 5% or 6%, something like that. Depends on the pool rate. And that will allow you to get that SPP for a year. And now you can mint 1:1 million ETH backed with the RSTs because that ETH is reserved for you. ETH will never go to anyone. And this is the characteristics of the K2 that we explained in our earlier presentation was like no double stake, nothing at stake and all this kind of stuff. This will enable it. But we're going to walk you through all the details of how this thing works and what is an RSC, how it can be done, how easy it is, how it could be useful. All right, so let's go into it.
One of the most common things people were asking us about is like, what's the difference between global security versus local security, right? And I think it's quite important to understand with K2, right? Both are possible, right? But default is global, right?
Right, because it is based on a network theory, right? So you are taking an SPP for a network, but if you want to, let's say you have Ethereum, the question here is, have you ever waited for more than a day because a couple of attestation missed in Ethereum?
Or wait, like you mean like waiting for finality, to do my next transaction, if I'm trading?
Yeah.
No, I just do it as often as I want the transactions.
So the decentralized networks by default are allowed to fail, right? That's how it works. And if you think from a perspective like, oh, the decentralized network should not fail, then it is not decentralized, it's centralized. So the ethos of decentralization is like you can come back and the network will just go on, right? So the network will have a network level fault tolerance, but then the actors have, each and every actor is enabled in this kind of staking mechanism, and they will get the rewards based on what they're doing. And that rewards will also get you slashing. So it keeps a book of your activities. The software can track the off-chain computation. So if you're a node runner and then you're running it, you may not have 100% uptime for whatever the reason. You may lose some money, but that doesn't mean the network is less. But if that's the case for 20 to 30% of the node runners, then network has a liveness problem, right? Same with the HCC and same software run. Not HCC, like Ethereum Classic, and difference between Ethereum. All right. So in a way that, and how do you, how can you make things much more right? So how can you make things more granular at the local level? So the local level is the node runners, right? How can you get this kind of thing also be replicated, right? If you want to have like 100 node runners to run, and it could be node runners from anyone, from your preferred node runners, from existing node runners who are in the marketplace of K2, or from outside, you need a token that actually tells you what happens where, and then you can put that into slashing or staking economics at the local level, and then you can actually take the network coverage, slashing coverage from the K2, and the total security is also there. This all very interesting experiment, but the K2 by default will allow you to secure any kind of networks, any kind of service logic, and slashing. Now with the RST, you will be able to do much more tokenomics around it. How do you want to do this kind of early experiment? You know, this I have a lot of questions in this one.
Yeah, the design space is quite open, right? But clearly every or most restaking applications or networks, they will have their own native token, but that requires bootstrapping, incubation, and the RST will bridge that chasm, right?
Yeah, it really opened the design space wide. Like it's very flexible, right? When you have a token and you want to onboard the community, you want to give them a role, like someone is node runner, someone is other things. You can actually simulate a market for that. People can buy it from open market. If you have an RST, it's an ERC20, right? And it could be traded in DEX. It could be even given to other networks. We have people who want to, dock other networks with a K2, so they can actually have ETH back security and the liveness for attracting more things. Could be anything. It could be for Web2 service layers. Like, oh, okay, now we have some decentralized services that we're launching, like for example, this kind of P2P layer that the guys are talking. Now we need a token that people need to stake for that specific service. So we will slash each of them, and if the service is degraded, then we also, the network will also get slashed. So it's kind of local and global. It's pretty cool.
Absolutely. I really like this idea of decentralized experiments. So the ability to, sometimes experiments, might last a month, and the output of that, is obviously down to the application. But this really allows more innovation to happen quite rapidly in the space through the use of the RST.
The cost wise is very less, right? Because you are getting an RST with the ETH backing, so there's some sort of a base. What is your economic security that tokens are worth of? Because there's a token sitting there.
Right. But it's not mandatory, right? So if your restaking application doesn't need it, obviously you don't have to mint the token, but it's there. It's a way of tokenizing your
purely opt-in. Yeah, it's purely opt-in. Yeah.
Right. So I think we need to talk about the SPP, the stake borrow position. So and how they are the base for how it's the base for the restake stake tokens. So so ETH security is being pulled together in a lending pool for others to borrow, right? So they can make like so when you borrow, you define your risk profile of your application, right? So you define that in terms of your liveness and so you have two types of main of events. Sorry, two types of events that can happen in any decentralized network. So they can broadly categorize into two categories: liveness and corruption. So liveness is what you were saying about the network is just not available for the end user. And then corruption is a violation of the protocol, right? So different when these events happen, it will impact different applications differently. So the risk profile is the stake. What do you call it? Stake risk profile is different amongst those, right? And you're just tokenizing
every SPP is a micro network, right? Within that the K2, so you can have hundreds of networks. SPP 1, 2, 3, 4, 5, and every network is different. Every network has their own characteristics. Every network could be an L1, or could be just an Oracle, could be some sort of a services, but they have their own requirement, why and how they're going to use this.
Is there inter-network contagion? Like
No,
can the
no. So
contagion spread from one
no,
network to another?
that's what we're showing. It's compartmentalized. So an SPP is an SPP. It will never get to the stakes. This is very interesting because in K2 the deposits are fungible. So how can you use it? So you can in deposit and withdraw. It doesn't really matter. When you withdraw and deposit, like your yield will get adjusted. But when it gets assigned that staking for SPP, or every SPP is unique and non-fungible each other. You cannot just swap one SPP for another SPP, right? You can terminate your SPP and open a new SPP. That's fine. But the two SPPs are not fungible, but the underlying backing of all ETHs are fungible, and that's the cool thing. You're just abstracting away from you have ETH. None of the validators in the ETHs are fungible. You have the same thing, but every stake weight is fungible, right? within when you do this the rewards and everything, and then you can calculate how much they will get it because it's ETH at the base, right?
And every RST is mapped to that SPP, which is non-fungible, but the RST will so each piece of an RST maps to a unique SPP. So in the network that's fungibly tradable, no problem. Right. Okay. So what you were saying as well is so you can have local level slashing. So these RSTs could support any kinds of new applications, and the RSTs could be staked to run additional software for a network, and you can have local level slashing if you wanted to. You can also use this to bootstrap an application, and this could be the token that gets converted into some kind of a native token later, potentially, or it can sit side by side. So we can get into that, but right here we need to really talk about a native delegation. So that is making the ETH at stake. So the ETH at stake is what's fitting in the consensus layer. So in the consensus layer, you have you can actually go check the Ethereum deposit contract. The ETH never gets burned, right? And that is used to register validators on the consensus layer. We'll get into the mechanics in a bit, but that is ETH that staked ETH that then can get that staked balance can be replicated into the K2 pool to make it available for restaking in other applications. And the beauty of the K2 protocol is you can do this without any changes to your existing withdrawal credentials. So we are solo staker friendly, and you can support the entire network. But
everyone is treated equally.
Right. Even if you're a DVT operator, you could be a big DVT operator, you could be a solo staker. Everybody has got equal participation here.
Yeah.
So that well, I mean the number is going up, but that's $51 billion of e-security, ready to deploy to other networks. And we're actually going to show in this conversation, we're going to actually show the sidecar ecosystem software that you install on your node. It's compatible with every client combination. It sits alongside Boost and everything, and you can natively delegate, and your validators will interact with the Ethereum smart contracts, which is incredible. So it's really wide open, right? It's really, really wide open.
It just basically make the ETH-backed restaking available for everyone everywhere. You can start having staking networks backed with ETH like a matter of minutes, right? It's so easy as it would be. And you could do all kind of experiments with this. You could use this for DeFi protocols. You could use it for certain things you want to do with the DAO. You get a year for this one. The tenor is at the beginning. The K2 is giving on a yearly basis. So, but there's a question, right? The lease tenor. What happens if you don't renew it? What happens if you don't? We need to discuss this. Like we need to give a hype. What is this? What happens?
Yeah. So here we give the key points really for that, and we can just expand a bit about them. So the ETH, the restaked ETH, can be borrowed for a period of a year. You can increase your your lease position. You can increase that if you want. So you can start today $100 worth of ETH, and you can scale up to $1 million. As your application grows, you can grow as well and increase the amount of restaked ETH that you need for your application, through the SPP. So the SPP is the that position for your application, but it's a year-long lease that will auto expire. Once it expires, it goes that restaked ETH in the pool can be borrowed by another protocol. So before you need to decide, before it rolls over, you need to decide whether you want to renew again for another year. You need to you need to be quick, because once that is gone, there's many applications that want to use it. Like you were saying, there's all kind of people wanting to dock chains into ETH, docking Cosmos, and there's like all kind of stuff that's happening. So there will be demand for this. And the RST will be mapped one-to-one to the SPP, because every SPP has a unique index. So this means when the year is up, if you're going to extend and create a new SPP, either for the same size or more, that RST will be in the protocol, will be automatically remapped to the new SPP. So at any point, so this is what we're saying here in the RST side of the slide. So a holder of an RST can check the actual token and see if there is an SPP backing. There is a simple function that anybody can call. It's just the function name is active. You can call it on Etherscan. You don't have to be technical. So you can check if the RST has an SPP backing. Otherwise, if the SPP is expired, or there are some other scenarios where the SPP can get liquidated. So if there is excessive slashing, and the SPP is not topped up, eventually that can lead to the the liquidation of that, and that will make the staked ETH available for other protocols.
How do you know that there's the RST doesn't have a backing from the SPP? The SPP has been terminated or liquidated in this case. Is it possible to see somewhere that you track this RST tickers, and RSTs are ERC20 tokens, but you can get this from a graph or anywhere that the lease is expired, the status of the RST token active, or orphan, or lease is going to expire within this date?
Right. So kind of so in Polkadot, obviously the leases there are 2 years, and they do have a dashboard where you can see who's leased the dot and when that expiry is going to take place. So it's pretty simple for anyone to actually track this information and spin up a similar dashboard, because it's you can do it from the graph. Like if you want to do it at a global level and list all of the RST deployments, so with the graph you can use templates to basically track all the RST deployments from the factory, and every RST has this function is active, and you can just call it and it will just tell you true or false. False means that there is no backing, it's orphaned, there's no SPP there. You can do it at an Etherscan. You can do it from the graph. You can query the contracts directly from an OGS script. There's actually it's actually super easy to find out, and it's updated. It's all on chain. So there is no, you can find out instantly when the SPP is about to expire, when it's been liquidated, when it's not got any backing. It's all there on chain. So that's I'd like to see a dashboard, community spin up a dashboard for tracking that. That would be really cool.
But you're saying that this is available from the contract itself. If you want to,
there's no special tooling.
It's all available on chain, right?
Yeah, which means even non-technical people will use it, because if at a minimum you can go to Etherscan, then it's just a simple, you can check in a UI. Yeah, you just go in your wallet on Etherscan, you check the RST that you hold, and then you can click read contract, and it will show you that it's not active. So that'll makes everybody smart, right?
Right.
But maybe we should talk about as well, like, so that takes care of the, what am I holding? Is it is the underlying SPP active and stuff? But so what about the supply dynamics here? So we're talking here on the slide about incentives. So when you open the SPP, let's say you have $1 million worth of ETH security. So you can mint in ETH terms. You can mint a 1-for-1 an RST up to the max supply of your SPP coverage. And 10% of that will go to an incentive pool to incentivize the restaking to stay in the lending pool, right? So that will keep the restaked ETH in the pool, which is important for the SPPs because you don't want the nothing at stake problem.
Right.
You don't want to. And then that reinforces the RSTs as well.
So this thing is like, if there is no stake, the SPP owner will not get charged. The money will go back to them. The pool is not going to take so whenever you open an SPP, you have to pay usage fee upfront, which is like a small percentage of whatever the security is. If you get a million ETH, maybe you pay like 5% of that. But if there is no stake, that money comes back to you. Right, that's the pool, right?
Which is fair.
Yeah, which is fair.
Yeah.
But RSTs can still operate.
Yeah, that's true. That's true. Yeah. I mean, normally when you launch like a new chain, you have a native token. It's kind of like minting those kind of But here you're backed by the security.
What do you want to redock it? What do you want to reactivate an the SPP and say that, oh, no, we need the ETH backing. It's got liquidated, but can we go back? Second chances.
You can absolutely. If there's ETH for borrowing from the K2 protocol, then you can you just borrow the ETH and it will get automatically remapped to your the original RST that was deployed, and then it will have
it's like a zombie.
Be restored.
I'm coming back. I'm here. You thought.
Exactly.
I'm dead. I'm not dead.
Yeah, exactly. So how do you think this can help DAOs, Matt?
Well, the DAOs normally get spun out for an experiment, and the DAOs, we saw the shit show in OpenAI and all this kind of stuff, right? But you can actually have a DAO to set up and say that some of the governance actions or even the treasuries, they can change the rule, but then you get like a very independent token that is backed by ETH, and then you can keep this kind of a dual governance or tri-level governance or whatever it is. You can get the representation based on what they were interested in. So that the DAO holders will actually govern that, and if it's not working, then do another one, and then you can have another token. But it doesn't really give a lot of pressure to you. Like you have like a full network level token, but this could be like 20% of your network. But once you have ossified yourself, like your DAO structure, then you can have like, okay, now the RSTs can be converted into a DAO tokens, like a very different tokens, but it can happen. The DAOs can immediately get a governance token at a low price with the ETH backing, but then new people can join the DAO governance by buying this token from outside. You know what I'm saying? So because it's tradable, but then initially you can also incentivize existing DAO holders, whatever the DAO is doing through token supplies. It's just like any other tokens. So you can have your mark certain percentage for the users and certain percentage for the outsiders to come in, and they're really interested for or NFTs or you name it, any kind of any other DAOs. But then you can experiment things much more faster, and your tokens are ETH backed. So all kind of experiments. The surface is super wide open, and the tokens will bring all kind of actions here. And the DAOs could be just for service operating that you are. Say, oh, I'm just setting up a DAO. Just want to do a bunch of guys are doing some service for my product, and this is not the entire product lineup, but this is a specific part. And I need you to stake this token, run a machine, and tell it in a software and tell the world how we're doing it. Or this is kind of called crowdsource intelligence, crowdsource experiments, whatever you want to call. but at like iterative, it's kind of a loop. You can start over. You can refresh it. You can go from like very naive idea to a very ossified idea market fit to a product market fit much more faster without having much capital at play, but it will give you that security because the decentralized networks need the security. So you don't pay for the entire security, but you can actually experiment with that with the RSTs. That's more important. And if your network is performing very good, your RSTs could be traded on a bow. What is the backing value? Because if people are saying that it's very hard to get in, I mean that's a dynamics, but that's how the companies are. Like someone you raise I don't know 100 300 million doesn't mean that your market cap will be 300 million.
True.
The shares
very,
will
very true.
in a different way. Yeah. So the equity is an endogenous value, and the external markets are looking after to get into it. So you can do anything with this. The cool thing here is not only on Ethereum, you can do on any networks, any blockchains, anywhere with ETH backing. So ETH is becoming the base for decentralized experiments, a decentralized future, a stepping stone.
Yeah, all the technology supports the ED curve and all that kind of stuff, and you can do all kind of stuff. So I would also add like what you said about crowdsourced intelligence and stuff like, but you also have like community operations. So your DAO network can run reports as this. Some people are calling it something like observability gadget, whatever they want to call it. But so these reporters are just working for the network, and they'll get paid in ETH for doing that job. So rather than running crazy operations, everything yourself, and supporting and struggling to scale, you can basically say there are certain operations that need to be taken place by the community, and you can run a reporter to make sure the system is running okay, tell us if something isn't running okay, and you get paid for that.
Yes, you can actually use reporter package to create your own reporting functionality, and then you can give them these tokens, and then that's their revenue. Oh, that's pretty interesting, because we saw that like any kind of RPCs or any kind of things you want to do certain tasks. Now you have it. If you want to watch out for liquidations in your protocol, you give these tokens and they run for that. If you want to have a solvers, boom. Oh, I never thought about this. Like you can use it for any kind of arbitrary operations. That's great.
Yeah. It helps protocols grow sustainably. It's all about sustainable growth with
because
running some operations are have high burn rate, but that's not sustainable. And it really makes the barrier to entry really high, but it's bringing about those barriers to entry low.
The RSTs will actually reduce order of magnitude your cumulative burn rate if you want. Like in your entire lifespan, this is just going to shrink it, but it's just going to expand and exponentially increase your cumulative value accrual at a very, very flexible manner. Yeah.
Exactly.
Oh, this is
these diagrams here on the screen just reinforce what we've been talking about. Is there's obviously ETH that is restaked via Native Delegation into lending pool. That's here. LSTs can also come in and offer, because they represent some validator somewhere in some protocol. They can also, those are pooled LSTs are pooled security models, so they come in here as well. And SPPs are the non-fungible positions for each application, and you can mint the RSTs on top of these. The available to borrow is any capacity in the protocol that's not is not there. So this needs to be incentivized correctly in order to offer the restake these for other applications. And here on the this is covering the minting. 10% is for the incentives. There is a take rate for the service of the protocol, but other than that, it's used for the incentivization of the native delegation in the K2 lending protocol. But what if for the usage fee, right, Matt?
Yeah. What
you have to pay that up front normally, right?
Yeah, the usage fee you have to pay up front. This is the take rate. the usage fee for the SPP, which is basically like, you go and you specify how much ETH that you need, it will give you some ETH pay. But when you mint an RST, we are only talking about RST here. The minting has a minimum take rate for the K2 pool LPs. Maybe explain a little bit why that incentive is very much required.
Yeah, so these will get dripped to the entities that are providing ETH for restaking to the K2 lending protocol. So they, the longer that they stay in, they get dripped RSTs.
It's a mechanism that will prevent nothing at stake problem, right?
Yep.
Because if you don't have ETH at the base, then your RST will actually going to get orphaned. So we don't want that. So it's better that you give a certain amount of the supply to the K2 pool.
But what about the opening of an SPP, right? You got to pay a utilization fee to use that restaked ETH. But what if you could
right. This is like someone is ready to lend you that money. So why do you pay yourself as an SPP owner if someone can pay you for it? So when you can borrow that money, and now we have an RST to return it for them. And if they're interested in your RST, if they're interested in your network, if they're interested in your experiment, they can fund that, right? It could be an LP pool, just simple LP pool that's applying that. A 1 million RST could be minted if, let's say it's 5%, 50,000 worth of ETH, and that's the cost that you need to pay upfront. And again, if it's get liquidated, it's going to come back, but the loan can become from them, and you earmark certain amount of RSTs go back to them immediately. And it could be done from a contract. It could be done manually, like you just borrow and if someone just give you and then you give them manually. But it could also be done from a contract. So if you approve that loan and then you call the SPP whenever the RST is minting, the pool will get immediately whatever that you agreed beforehand, right? That's what we're showing.
Yeah.
So trustless negotiation for spinning up your SPP and RST.
Yeah, correct. And anything in green is outside of the K2, right? This is standard crowdfunding contracts. Just there's plenty available. Just deploy it, and
Yeah, it's purely anon friendly. Like anyone can do anything.
Shadow coding friendly. So yeah, this is just reinforcing what we were talking about. So RST they will start backed by an SPP, but in time they can get orphaned, or the SPP of acting can disappear. So it's important to keep an eye on that. But the ETH security can be increased at any time to reinforce the network. It is just a matter of going to the contracts. You can reset the duration. You can make the duration. If 6 months in, you can extend another to another 12 months. So you can make the SPP position bigger to get more security. It's really flexible in that respect at a protocol level. So this is a nice way to understand the the platform. So you have the Ethereum validators that are natively delegating to K2. Users are creating the SPPs on top of that, and then you have the RSTs minted from the SPPs, and you can then create your applications, your middlewares, and stuff like that. And maybe if you're spinning up a chain, your RST will be your initial token that maybe gets converted, or it sits alongside your native token. It's an incubation, for your protocol really, and it's really up to you how you want to use this. All kind of things are possible, really. We had so many people swarming us, like, oh, can I do this? Can I do that? Can I, how do I use this? Can I see the docs? And so the design space is really interesting here. Right. Sorry, 1 second. Matt, can you take this this one? I just need to mute.
Yeah, no problem. So, right, if you look at that one, so the open hours, this is basically how high level overview the flow diagram. So if Alice comes and opening an SPP, let's assume this SPP has a slashing coverage included. So that's like, we're going to discuss this. This is two partitions. One is the utilization rate and one is the slashing coverage rate. So the SPP is ensuring there's a network-backed security has been given, and the first service is the network-backed slashing coverage has been given. So SPP with slashing coverage. So you open a slashing, you set this maximum slashing for liveness and corruption. You can have up to 0.5 and 5 for liveness and the corruption. Now you said, whatever that is the maximum that you need, and I'd say 0.3 for per event for the liveness and 4 for corruption. You could have any number of events under the liveness, under the slashing, but it cannot breach this maximum per event. So you can have hundreds of them, could be same 3 or 0.2, 0.1, doesn't matter, right? So the important factor here is you cannot give more than what is being taken as a maximum coverage. So that you set. Now okay, I want to mint the RSTs too. I want to have this kind of the community experiment as well. So what happens when you click that button, when you have slashing, it will when the minting of RST happens, it will atomically do 3 operations. It gives you the RST as an SPP owner, right? It gives mint the tokens and comes to you. It will pay that 10% minimum, but if you set like 15%, then the 15% will goes to the K2 pool, and the minting rate to the cloud as well. But then it will also set the slashing coverage. So you have the RST tokens minted, you have the slashing coverage set up. The partition interest rate is one payment that you're giving. Again, everything you will get it back if you want to, if you just terminate it. That's pure and simple. And that's the terminate 24/7. So if you look at the SBP as a slashing and a stake borrow position, what it has after this minting, you have a complete an RST based staking, you can do it. So we have, let's say, if you take 1 million, you have 1 million RST tokens, you can inject a local based staking rules like, oh, I want to run certain operations to be require staking tokens with RSTs. You can provide this as an handed directly from a faucet, or they could take it from one of the dexes if you have a liquidity pool or trading pool there. So the staking is open, permissionless. You can have that. Permission or permissionless staking is available because you have a tokens you want to do any way that you want. You could also inject now local slashing logic that, how this operation should be. Each and every actor can be slashed in such and such way. And now that's one thing. So you have like agent-wise slashing can be injected with the RSTs. The network slashing is also given to you, taken by the SPP card. So let's say if your network is not really performing very well, people can actually see, and they only look at the network level coverage, right? Because that's what I said. Is the Ethereum confirmation rule is 2 epoch, and Ethereum classic confirmation rule is 2 days, right? Because it's 2 different networks. And network liveness and corruption will be tracked by the reporters, and they will do that. You don't really have to do anything. That's automated. That's been provided by the K2, but the local things you can have any way you want, right? You only pay usage fee to do all of this out of the box, and that's like, you can run 1 million ETH or 10 million ETH worth of experiment at a super low cost.
So this is a kind of like a, how do you do it, right?
Yeah, all of it. Click it.
Right. So we have a dApp. It's going to be available soon. It's working on testnet. It's been working on Gorilla for a while now. This is opening an SPP position, so it's just worth getting you familiar with the UI here. So you have the ETH, the restaked ETH that it's available to borrow. At the top here, this is this is an example rate since this is a screenshot, but this is based on utilization. So that will be the rate if there was high utilization. But that this is just an example. This is not really the rate that it will be there, and there will be lots of native delegation coming in to kind of like find some kind of equilibrium on the rate, really. So you specify your borrow based on how much there is to borrow. Your designated verifier when you're creating these positions. So the designated verifier is when you take on a slashing security, right? When you're specifying that you require a slashing coverage, then basically you're going to specify here the liveness and corruption, and you're going to, this is the designated verifier that you assign, a middleware that you assign that either you run yourself or somebody else is running, that will verify liveness and corruption events and authorize slashing. It's a predefined package available. I think the GitHub is Restaking Cloud, I think it is. But so you inject your slashing logic there. But here you can opt into the RST token when you're creating the SPP. You specify your ticker. It's up to 6 characters, and the incentives that are being allocated to keep the coverage in the K2 lending pool. And you will have some kind of a interest payment. What is it called? Not an interest payment, a utilization fee. And that pretty much it. It's super straightforward. This can be programmatically done. We have a cloud SDK. We have a K2 SDK, and we've got a plus sidecar ecosystem, and more. So there's really it's kind of up to you how you want to do this, really. So.
So the guy who's minting the RST only need to do this, right? He doesn't really have any kind of a logistics associated with it. Just click the button and he will receive the tokens, and then.
Yeah, absolutely. It will come. The borrowing amount will be your supply of your RST, your initial supply of your RST, minus the incentives that you've allocated to the K2 protocol to keep the. Yeah, that will come to your wallet.
Cool.
So we always like this meme, from the supply side. So when from the ETH that you hold, as whether you're a solo staker or a big entity, the ETH you hold, is staying in your drawer credentials, right? And you can participate in the K2 protocol, simply proving you basically, to do the native delegation, you prove your ownership and you delegate to the K2 protocol. You keep your security, you keep your operations the same, and you earn more ETH. It's like quite straightforward, really.
Right. So you don't really give your withdrawal credentials to anyone. You don't change anything in your operations.
No.
Just allowing people to reuse your ETH, but you should get paid whenever they use that one for.
Yeah, absolutely. So this is powered by our technology, right? The validator state replication technology, right, on the execution layer. So here we have. So okay, what we want to do is talk about something familiar. Everybody understands. Everybody should understand elements of what we're talking about on the left side of this diagram. So we have an Ethereum chain that under the hood is composed of 2 chains. So we have a consensus layer and an execution layer. Execution layer is docked into consensus layer. So consensus layer is obviously offering the consensus for the execution layer, and that's the only purpose of it. And that is run by consensus layer validators. They all have BLS credentials because the consensus layer is operating on the BLS cryptography. So that specific curve is the 12381 curve. And the reason I mention that is because natively in the Ethereum execution layer, there is no support for curve verification so that means normally this is really challenging. But what's interesting is that the Ethereum consensus layer cannot activate or append any validators to its registry of validators without the Ethereum deposit contract, which is set on the execution layer. So on the execution layer, you have a contract. You can go to Etherscan and you can type into Etherscan deposit contract.eth somebody amazingly mapped that ENS to the Ethereum deposit contract and burned access to it. So it's like therefore, so you can easily access the deposit contract. You can see all the ETH is there, all the security. Now, in order to register a validator, you need to send to this contract. You can see the source code. You have to send a minimum of 1 ETH into this contract as a spam protection mechanism to register a validator credentials on the consensus layer. So when you send that transaction to the Ethereum deposit contract, your registration transaction, normally people send 32 ETH, but we're illustrating the point here that you can register any credentials with 1 ETH. It doesn't mean you're going to get activated. You need 32 to be activated, but you can fire the transaction to the deposit contract, say, hey, I want to register some credentials for the Ethereum consensus layer. This is the BLS key I'm registering. I'm going to prove my ownership to you, Ethereum deposit contract. I'm going to sign a message and give you a message that will allow you to show you that I own a BLS credential and I want it registered on the Ethereum consensus layer, and I want you to add 1 ETH of balance to that BLS public key. And then it will go through a cycle, right? Then if you add another 31 ETH, you will then go through an activation cycle. You have different induction balances, effective balance, slash balance, and you can manage your different states. But you will specify when you do that registration a withdrawal credentials that you control. So in a similar fashion, we do the reverse with K2, but we're leveraging the proposer registry. So the proposer registry is a smart contract on the Ethereum execution layer that tracks active consensus layer validators with a minimum 32 ETH effective balance. So you can basically prove ownership of your keys of an active validator on the Ethereum consensus layer, and you can say, hey, proposer registry, I want to perform a single sign-on, right? It's just like a Google thing or this single sign-on can be used anywhere. Hey, I own this validator. Here is a message proving that, and I want it registered on the chain. And if your active status, if your minimum balance drops or you're kicked from the consensus label, can get reflected on the execution layer as well through that. And K2 is just an application on top of this proposer registry. The only thing it requires, you to do, it doesn't require your withdrawal credentials, but it just says when you earn money, where should we pay the earnings, and that's the fee recipient part at the bottom. So, am I missing any kind of details here about the life cycle flow of the registration?
The one thing here is a pure and proposer registry has a rule which kind of validator minimum ETH to effective balance means. It will not take any kind of exited validators or anything like that. It only takes the active validator in the consensus rate. So it does a lot of checks. It's really replicating the state from consensus layer to execution layer on a smart contract. And it makes sure the registry only keep an active validator with a minimum 32 ETH. Once you register, that doesn't mean that you will be there forever. You will get kicked out. So that's all part of the proposed registry. Proposed registry make sure you can just outsource your onboarding validators from consensus layer to execution layer for your smart contract. Just call the proposed registry. It will do the job for you. Free. It's already on for the last 6 months.
It's already there on mainnet. Thanks to Runtime for helping us on that front.
I mean, this is the part of the PON, proof of neutrality, like the platform for any kind of experiment in a docking consensus layer into execution layer, and you can build anything on. You can do a maybe supply chain, you can do restaking supply chain, you can do other stuff. But this is something that we worked last 10 to 11 months. Just make sure bringing auditability and verifiability on how do you negotiate with the validators. And it's purely a public good. And we just, we are deploying our applications on top of it too.
Yeah, absolutely. That's PON. That's the PON.network. That forms the basis for this. That's awesome. Yeah. Couple of things to mention about the management of the balances on the Ethereum consensus layer. So typically you have two balances. You have an active balance and an effective balance. All your voting and your earnings are done on your effective balance. so that it's not Ponzi and stuff like that. But your active balance is, where your penalties are reflected on your BLS key. So, as you mentioned at the start of this discussion, we Ethereum as a network is very, resilient. One validator being offline or inactive is not going to affect the entire network. But if you had 30% of or 33% of the the validators offline, then you've got a serious liveness problem at the global level, but not at a local level. And those validators will incur penalties. If you do a double signing, you'll incur some more severe penalties. So Ethereum normally has this like 16 ETH auto kick threshold. So when you reach the 16, you'll get kicked out of the network. So in order to avoid excessive management of state and stuff like that, the stake weight inside of the K2 lending pool is 24 ETH for a native delegator. So when you're natively delegating your consensus layer balance to K2 lending pool, your weight is 24. And that accounts for more than enough buffer for things being offline. It creates a level of resilience in the protocol. What would be great to do is to bring Andreas into the room and talk about the configuration of your SPP position and what is behind the utilization fee that you're paying to open a SPP.
All right. Right. So when you open a SPP position, you pay an interest amount upfront, and this equation we have here on the screen is the formula for the interest rate. What you do when you borrow, say 10 ETH, you say you want to borrow 10 ETH or 10K ETH, and then you will pay an amount, an interest amount corresponding to what is required by this interest rate on the screen. And the interest rate is partitioned into two partitions. First, we have the B partition, and then to the right we have the other part. And the B is based on the current utilization. That is a part of the partition of the interest rate, which is becoming higher when the utilization of the K2 pool is high. That means when there is a lot of borrowers and a few lenders, then the utilization rate will be high. And conversely, when there are a lot of lenders and a few borrowers, then utilization will be lower. That is one part of the interest rate. The other part of the interest rate is based. Go ahead.
So even in that, right, there are like a number of parameters that are predefined upfront on deployment in terms of like the maximum the utilization rate can be, the breakpoints and all that kind of stuff, right? It's quite familiar territory for some people that understand. Yeah.
Right. So yes. Yes. So the way that it looks it's like a function with which first typically it will be based on the utilization. At some point, well, in the beginning, the utilization. The utilization partition will increase slowly until we reach some utilization percent, and at that point it will start to increase faster. That is typically how it looks like. It doesn't have to be like that, but that is how it typically is. So that it is right. So to incentivize new lenders into the K2 pool, so it starts to increase faster, and there's a lot of utilization.
What is this interest rate? You take the money, but if they terminate, it will go back. So the interest rate is not consumed immediately, right? It will be consumed during the tenure of the SPP, and it will be consumed by the pool will get consumed by all of this, an aggregate yield will derive from this interest rate for each SPP. Each SPP will have its own interest rate, right, based on the parents.
Yes, so based on yes, the interest rate is calculated with this formula we have here on the screen. So it's based on in part based on the current utilization, and then also the slashing parameters that are being provided.
So there could be two different SPPs, like, so because this slashing partition is kind of like optional, right? People might not need that slashing, right? So you might say, there's no slashing penalty for liveness or corruption, and then you're just paying utilization for that security. But like I could have a 10 ETH SPP position, and you could have a 10 ETH, but like you could be 5 days behind me, and like so I could. You say obviously on the utilization side you have like a base utilization rate, and then I could take it on day 0, but by day 5 there might be a large amount of utilization, so you're going to pay higher usage fee than me, even if we're borrowing the same amount. So but then the slashing is different, right? Because obviously there's like some negative covariance here with like the amount the coverage, right, you take. So it's like it will reduce like the amount you pay on the slashing, because you got more ETH security at your disposal. So basically, when events take place, you got more buffer to deal with it, right? I don't know if I'm butchering this. I don't want to butcher the partition in the intraday model.
I think it was fair. So yeah. So another thing I want to add to what you're saying, like if you borrow first, and then at day 0, and then I at day 5 borrow, then if there are no new lenders, definitely my utilization rate will be higher. But it could be like there will be a lot of new lenders coming in, and actually my utilization rate will actually be better than yours. It depends on the market.
Yeah. So early SPPs will have extremely very low usage fee, because the utilization rate is very low, and they will enjoy it for that year. Oh, that's cool.
Yes. Yeah. So yeah, that also incentivizes early adoption.
Okay.
Right. So let's get to the part with the slashing, which is perhaps the more interesting part. It is based on this lowercase l and the lowercase c. The lowercase l is the liveness slashing amount. That is the maximum slash amount that is allowed per liveness slashing event, and the lowercase c is the corruption slashing amount, the maximum amount that could be slashed on a corruption event. These two both have an upper bound. The upper bound for the lowercase l is uppercase L, and that is based on the way that the upper bound is calculated. It is not a constant. It is calculated based on the utilization rate, and also based on the amount that is being the amount that is being borrowed, the principal amount. And this, what we're doing with the lowercase with the uppercase L, is that we want to ensure that we can support at least a certain number of liveness slashing events. I think that currently we want at least 5 liveness slashing events. That is a constant currently, but we can change that constant. Maybe it's not exactly 5 at the moment. I can't quite remember, but let's say it's 5, and then that means that initially the initial interest rate will support at least 5 liveness slashing events. So to have some buffer, so there will be some time to top up if the SPP is slashed. And similarly with the corruption, I think currently we want to have the uppercase K is the upper bound for lowercase c, and that is ensuring that we have let's say at least two corruption slashing events. So what the slashing partition ensures with the lowercase c and lowercase l that can be chosen is that we support at least 5 liveness slashing events and at least 2 corruption slashing events based on these maximum values for liveness and corruption.
It's like, when you say support, like, so this is like to allow enough time to react, right? So basically you can top up your SPP and recover the losses, right? So otherwise you will get otherwise the SPP will be automatically terminated and liquidated.
Yes, that is, yes. So that is 5 liveness slashing events and 2 corruption slashing events is supported. But if more than that happens, then maybe it may be get liquidated. But this is only if you choose like L to be the maximum and C to be the maximum.
Nice.
So yeah, so these are upper. So the uppercase L is upper bound for the choice. So these L and C are parameters to the interest rate, and they need to be chosen such that L lowercase L is less than or equal to uppercase L, and C must be less than or equal to uppercase K. It makes the interest rate higher because there is more risk involved. So when there is liveness slashing and corruption slashing involved, then there is then that actually the slashing happens on the actual interest rate, which is affecting the lenders. So that is actually they will actually. So when a slashing happens, the interest payment for the lenders will actually be lower. That will be decreased. So that is why the interest rate is higher when there is slashing involved.
Got it. Yeah, the threshold here at the protocol level is if 30% of the outstanding interest is slashed. The outstanding could be obviously if you have a SPB that's got a year's coverage, 30% of the so that the utilization fee that you're paying obviously gets stripped over the course of the year. So what is outstanding is relative to time, and so 30% of outstanding interest at day T0 is going to be very different to later on down the line. So, but when it reaches that threshold, so that means that they're at the application level. So that network is experiencing the network that is taking the SPP for the restaking application. There is some problem, spilling into the global coverage that is causing excessive slashing, and it's not not helpful to the global coverage. So that application needs to fix obviously the software and the issue associated with that, and that means that the SPP will get ejected and it needs to be adjusted, and then it can come back at any time. That's not a problem. But it's about offering this this global security really. But we can support different every application will have a base utilization plus some kind of partition. So slashing application has a slashing partition. Additional partitions can be supported as well.
Right. So that's very modular how it is, and it's also limit contingent. Like if the slashing is going down, and how it's going to affect the utilization at the entire life cycle. It will just get reconciled, but it also helps to be buffer sometimes.
Right. Always.
Yeah.
So if we don't have any further things on that side, we can jump into sort of native delegation with MEV+.
Yeah.
So we talked about aggregated, we talked about these network level things. So
let's see how things work.
Yeah, let's see how things work, because we have this slide from Istanbul, but maybe if I can hand over to Ronnie.
Yeah.
Okay. So having gone through K2 and how you could possibly delegate your staked position to earn like further revenue in the K2 pool, to more or less join this pool. Of course, you can join by means of the dApp, but more securely, we're trying to create an environment, especially around our new software MEV+, to onboard these more or less sidecar applications to node runners, to be able to, from your node, enter some of these applications or some of these pools for your greater benefit or for your revenue directly from your own local instance. So just share my screen.
Yeah, sure. Feel free to take over.
Yeah.
Okay. Yeah. So the idea is with the K2 delegation module, you greatly benefit from the securities as a validator, having to join the pool and then offer your stake position as a possible revenue stream. As mentioned, it will be locally run, locally managed. You have the full overview of what the module is doing and have the flexibility to set what actions you want to take whilst being a member of the lending pool, and then allow for further restaking or to customize the staking outputs. So if I would go through the concept, it's no longer a concept, it's a working solution of MEV Plus for validators. The idea is as a initial proxy software to the validator. 1 second. So as an initial proxy software to the validator, that's a little up. You have the possibility with your consensus operations and activities to connect with other decentralized applications or other, let's say, private mempools and other further business logic. One of them being the K2 native delegation module, which will give you access to the K2 lending protocol. So by means of this module, you can think of MEV Plus as a puzzle, a network of puzzle pieces of different allowable pieces, all of which eventually connects to a core. So you can build modules that work for your typical PBS order flow operations, but you can have additional modules that are attached to these operations or attached directly to your node by means of the MEV Plus core, one being the K2 native delegation module. So with the K2 native delegation module, we aim to securely allow validators to automatically and securely authenticate with the pool, assuming you have been registered on the proposal registry, and then delegate your current stake, having been identified on the proposal registry, to the lending pool. So I will give like a deeper dive into the workings of this module. So for this module specifically, without going through much code, the concept is every validator essentially would have a beacon or consensus client software. These consensus client softwares have been built to obey a spec, and leveraging this common spec across all clients. So with full client diversity support, by means of this builder API spec and beacon API spec, we can leverage different data points within the node for external applications, even on the execution layer from a consensus node. So one possible use of the builder API aside your operational PBS stream is to leverage the registration events or the registration endpoints by the builder API to further register your validator, not just with relays and other block building services, but further register your validator, for instance, in the proposal registry or in K2 quite effectively. And so by means of the builder API, so just to briefly touch on what the builder API is, as a consensus node, you have the option to expose external block building to either get blocked by means of a relay or external builders. With this builder API and validator clients configured on your node, there are these events of registrations that emit roughly every epoch by the node to this configured external body. And these events pass, for instance, if you're using a different validator proxy software, they pass to this proxy software, which will then emit these events to relays to register your, let's say, your gas limit preferences with the relay. And so effectively running your PBS operations. But with these broadcasted messages, the node more or less is making known to whatever proxy layer is built on top of it, what validators are available on the node, a signed registration of this validator's availability on the node to confirm its existence and ownership of the node. And so by means of these registrations, you can also prove the ownership of those validators on the execution layer as well. It's not pretty conventional that you could go straight from consensus activity, basically like your consensus events, activities, even like your change of keys on your node can almost instantaneously reflect on execution layer by means of the K2 module through MEV+. So with this, let's say, registration event that fires to the builder API, there is, yeah, sorry.
Just to touch on a point that so that means, because I know there's a like obviously a problem in the PBS space where basically relays are replaying registration messages to other relays to have like to sync all of their databases. But basically, if you have like a single on-chain registration, then everybody can sync that contract and use it for whatever application, whether it's PBS, whether it's restaking, and so on and so forth, right?
Correct. That's correct. And so you kind of have, of course, the single sign-on. So having that central point of truth, especially on the blockchain that is known and is not offline, that can be mutated, is a truth point for more registrations across different services, even off-chain services. Like if you have like multiple relays in strictly PBS you want to contract with, they could use the proposal registry we've gone through as a point of truth, as opposed to trying to relay or emit these registration messages across different service providers. That's correct. And yes, and so with MEV+, I'll just briefly touch on like the great granular and flexible nature of the MEV+ architecture and its and the kind of ecosystem it enables. So with these registration messages aside, your header and payload requests that come from your node for your typical PBS operations, these registration messages are handled by the builder API module. So I will just briefly touch that everything in MEV+, I would minimize these. Everything in MEV+ is very lean and modular. So the entire validator proxy software is simply these sets of folders, and the ones of preference or the ones of use to anybody building on top of this is the modules folder and the modules list. So in the modules folder, you can build any sort of application or software you want to provision for node runners directly through their node by means of the Beacon node, API, or by means of the Builder API or any other validator key management API that may be available on the node. You can build solutions or projects around that within your own contained folder or library, quote unquote, module, and then load it into the software by means of defining the service here and defining any custom commands that need to be passed into that particular service. So in this case, we have done so for the K2 module that would enable these registrations on chain through these consensus layer activity. And so returning back to what the Builder API essentially does is we have as a proxy software, when the registration messages come, there is a module called the block aggregator, which essentially would handle the aggregation of either blocks, headers, payloads, and even registration messages across different modules that want to be a more or less like a block source or a block provider. However, this particular module, which is within this folder, also acts as a hub to broadcast, to notify other modules of certain validator activities. So as a external app, as a module like K2, we can latch onto these registration events, even though the registration event is not fired directly at us, the module. So in K2 being able to handle, since it's like passing a passing of events and messaging and data types across, by the way, this is contained securely within the software. It doesn't get exposed outside. Data can be passed securely across different modules without the need to actually understand, let's say, the types or the logic of that module. You can get the data, the registration data from the builder API through the block aggregator and perform other logic based off of like that validator's activity for that given epoch. And so delving a little bit deeper into what how K2 manages this, I'll just quickly show you the essential things to note. So for the K2 module, you can configure the module to handle registrations on the execution layer within the proposer registry on its own, and also opt to delegate your stake to the K2 lending pool for, of course, further income. And by means of this, the things to make the setup pretty easy and lean, the things required and I'll point out here are a wallet private key, a beacon node URL, and an execution node URL. These can be set to your node directly. So in this case, for your on-chain activity, you can even privatize it in your own isolated ecosystem by having a custom RPC URL or node specifically configured for your module. So any transactions you even take don't need to show up on the global mempool if you'd wish. And then the beacon node, of course, is to latch onto your beacon node activity and confirm and validate against the builder API messaging activity that's occurring. Now, of course, on chain, every wallet execution needs so on chain every transaction execution like would need like an executing address to perform this activity on the contract. You can configure this to any wallet, like if you have a wallet abstraction, any address that can act on your behalf. But I must note that this address provided here, when registered in the proposer registry, would represent your ownership of that registration. And so it's by means of this address, if owned by you or any other entity, can you make further actions on your registered, think of it as we're kind of like taking almost like Web2's login architecture onto Web3. So you basically have the password to then later go into your account to, let's say, change your phone number, things like that. This is the address that would more or less be your ownership or representative address for the registry and Native Delegation. So ensuring that you do have access to this address or hold this address is essential to run this module. So with these provided keys, MV Plus out of the box can be configured with just the K2 module enabled, and we can latch onto this builder API messaging even without having to replace like your existing validator proxy software, or even without having to commit to a PBS operation. So you don't necessarily have to be running or building blocks externally. You just need this module enabled to as a sidecar ecosystem to perform these on-chain executions for you, the node runner. So delving much more deeper into what exactly the module does, these are so if you'd get more into MEV Plus, you'd quite easily like be able to get up to speed on to how to configure like your modules, and it's pretty lean being able to connect to the communication. Yeah.
Everybody writes a service file then, right? So if like let's say if I look at Native Delegation module as inspiration for creating my own module in MEV Plus, like so like the basic structure is you're saying I need a service file, right? With implementing the interface.
Correct. Yes, correct. So everybody kind of to use MEV Plus, so let's say the K2 module, every module or every project here essentially meets a service file spec. So this is the spec. It's kept really lean. So you have just the name, a start function to define any microservices you intend to start, whether it's a server, anything defining these function scopes would be fired by MEV Plus doing configuration, doing connection, and to start your module and stop it effectively and manage your own resources. And of course, the name is the identifier for that particular module or package. And so, yes, the K2 module does follow the spec. And in connecting, you can follow a few of these modules to see how to write these functions. These are the only required functions to attach as a module to MEV Plus. So you define like your service file. It can be any data structure, any service data structure, but it must have the wrapper commands to be able to identify your module, start any services you intend to run, and of course configure your module if you have any custom flags. And so that's actually the entry point. Thanks, Vincent, for leading to that. That's the entry point after knowing what flags are available on the K2 on your left. So in the entry point, you are basically configuring, you are passing all like your necessary flags private only to the K2 module. So if I must know that if you pass wallet keys here, they don't get exposed to, let's say, the relay module or the builder API module. You don't get like that leak of private data you are passing to your module. And so once that's passed, you can configure your module, and the module is written such that to check quite thoroughly you're configuring things correctly, because we are dealing with users' funds, with your funds, the use of your transactions. So we securely ensure that all contracts are available, validated, and have the right methods available, and identify you on all the supported chains, both your beacon node, execution layer node, and any signers you attach to the module. And so that's essentially what the configuration of this module walks through, and identifies the K2 contract address to configure for and the proposal registry address to configure for, depending on what chain ID you're connected to. So you don't have to, more or less, you don't have to figure out whether you're running for mainnet or running for Goerli. Spin up MEV Plus with a K2 module, and based on like the node spec you're running, we can identify which chain ID you're running for, the current sync and status of your node, performance of your node, and connect and configure the module accordingly when it's of, let's say, a write sync status, and of course a write chain as well. And so this is simply the configuration of this module. Now I would just I know I mentioned what these are about, and of course in like just a few minutes ago when we spoke about how the deposit contract, and then you have your withdrawal credentials for like execution layer for the Ethereum network. Similarly for proposer registries, you have of course a way to withdraw your funds, and by means of a payout recipient flag, payout recipient address. And so this address, if configured within the module, it doesn't necessarily have to be the address of your it doesn't have to be your representative address or the address that has ownership, because considering you have an entity that is running this entire infrastructure, and you want to pool all your rewards to a specific, let's say, syndicate, you can specify the payout recipient address to which payouts from lending into this pool or from registering in the proposal registry would go towards, if you are using the registry for PON or anything else. And so once this is effectively configured, you can more or less start, and this will start up with your node. And then on every registration message from the Builder API, we would have a sequential check, a sequential check of this registration message to perform on-chain registrations and checks for your configured validators. So just briefly going through the code, the idea is to obtain all the validator keys that are emitted by this message, and then run these validator keys through the proposal registry to identify which validators are registered already and which validators you would wish to register. So this proposal registry check is on the contract level. So this proposal registry check batches all available validator keys and checks it on the proposal registry contract for the proposals registration on the contract level. We can, considering that nodes have tons and tons of keys, this only goes as a slight overhead to the execution of the size of the call to the contract when you're later registering. By calling the contract, we can batch all of these key checks by we're leveraging the multi-call contract to batch all of these key checks at a go to optimize for speed instead of doing a single call at a time. And we also can effectively batch call to the execution layer node as well, different transaction executions at the same time. And so in checking the proposal registry results, you basically have a status defined in the registry. The status varies from you being active, unregistered, kicked. I could just pull that up quite quickly. So the status varies from you being active, pending an exit, being kicked, or you're active outside the pool. This status identifies in the registry effects of current activity or current actions you've taken as a node runner within the proposal registry. And this status can then further inform, and this is what, of course, the K2 contract and other application level other layered applications on the registry can use to identify valid validators for setting activities in the different applications. And so using this status as well, of course, that's what's so beautiful about the proposal registry contract is you would get this broad information without necessarily have to go node by node off chain. And then using this status, you can identify registrations needed to be processed and registrations which are already processed. Now, the node emits these registration messages, and so there will be a pre-signed message with its signature and valid public key, to which we can then use to execute the on-chain registrations. Now, as a node runner, you have the option to change the nature of this message. So in the case that you want to change the fee recipient, so as a node runner, let's say in performing PBS operations, you have a fee recipient that's specific for your MEV rewards or your block proposal rewards. You can manually change this within the K2 module, hinging on the fact that you have a signing service that can re-sign this message with that validator key. Again, for the registration, we are strong on ownership so that no one can spoof anything, and ensure that airtight security. And so you need to show proof that you have the ownership of that given validator to mutate this message, and then the module and of course the registry can use this message appropriately. And so one means of doing that is not required, but to allow that flexibility for all sorts of different parties or different use cases is to include a Web3 signer. So Web3 signer is a small package Java-based service, depending on what variation you get, that will allow you to on your own node without moving your keys anywhere to any external party, target your whether it's Lighthouse or Prism, whatever, target your key directory and then just load those keys for signing of a limited number of messages. So you can sign registration messages, attestation messages, and these are not things we are introducing. These are solutions and tooling that already exists that are already plugged into many of these consensus layer clients. So your consensus layer clients can actually out of the box use a Web3 signer URL for your key signing instead of loading the keys directly. This is beneficial for some parties who have like a centralized signing service, much more securely authenticated, where either like the keys are more distributed in a way to sign over the proposals that are running the node. But this is available within this module to allow node runners to change the fee recipient of these messages to vary from the fee recipient that is configured on the node for maybe a different wallet that you want to collect rewards and balance check later away from your PBS operations. So you can separate your funds or separate your revenue streams for like a better overview of your operations by this means. And so having identified the signable keys that are configured for that particular node, assuming you don't require that, it's not necessary, and so it won't go through that step. But it would process the registrations that are required to be processed by identifying if there's a need to change the payout recipient. So even if you have a payout recipient that is configured the same as your node, we would bypass this step and have no need to change the registration messages that come out of the node. But if there is a different payout recipient from what's configured on the node, then the Web3 signer is employed to sign this new registration message with this new payout recipient instead of the registration messages payout recipient that you've seen here. And so once that step is pretty much complete, for a conventional node runner who has no need to, let's say, change this recipient and have the same recipient, this is skipped over, and then there's a need to have a signature that is understandable by the contract. So this is where the signature swapper comes into play. So the signature swapper is basically a small attached service to the registration workflow where a ECDSA signature is provided that can of course the ECDSA signature is much verifiable on chain as compared to the BLS signature past the contracts, which is still stored and verified against your proposal public key. But the ECDSA signature provided by means of a signature swapper service can be used as verifiable proof against your BLS signature by the proposer for the contracts. So I will just show you what essentially this signature does. So with this signature, you have you may be familiar with this payload that's emitted by your node, let's say every epoch by the means of the builder API, where you've configured like a fee recipient, you have like a 3 million gas cap, a 3 million gas cap at a given timestamp. This payload with, as I've mentioned, your representative address is the address that you would more or less like delegate ownership of your activity on these registries to. This payload can be signed, can be verified for ownership, and then sign and return a execution layer verifiable signature for the contracts as well. So this is kind of akin to the same signature here. It's just a swapping of the signature scheme for the contract's sake. So depending on which network you're connected to for testing. This is go early. For instance, there would be a signature swapper microservice to provision this swapping of signatures that you can also check against. And so back to essentially what the contract is doing is in provisioning these signatures, you can identify validator keys that require that are they're really fresh babies that haven't been in the registry before. And on top of that, you can also leverage the K2 lending pool as a like a sequential operation to you registering on the proposal registry. So you may configure, you may not configure the K2 module contract address, and that can be bypassed as to your willingness, whether it's on mainnet or product and its availability. Yeah.
So shall we see this in action?
Yeah.
Shall we see this in action then? Yeah.
Yeah. Okay. So once the registrations are prepared, you can check the K2 module as well, and then for whether those registrations are available, and then the registrations can then go ahead to batch register your validators on the proposal registry, and then of course batch register your validators on the K2 module as well to natively delegate. And so to run MVP Plus, you can build, of course, you can build MVP Plus. We have gone through how to use MVP Plus. But to check MVP Plus's running, you could run, if you're not sure what to do or how to configure MVP Plus, you have other modules pre-built with it, and then you have like the K2 module where you can pass your beacon node, your ETH1 private key, your execution layer client, etc. And so considering that these events happen every epoch, and that's just for demonstration, what we don't want to necessarily wait for every epoch. You can mock these registration messages as sent to the signature swapper for like an ECDSA address would be mocked from like the node just to show like the operational use case of this module. Okay, so MVP Plus is up and running now. Should be about 5 to 10 seconds for the mocked build API registration event to happen. Okay, I took one of the keys out that we are mocking, and so we have 7 to process with 1 new key I've just introduced for proposal registrations. So it has sent the transaction to the proposal registry contract for registration. And of course, this is just waiting for the transaction to be mined to be sure you are registered on the contract. But this happens async, so you can be running your validator operations without this blocking anything whilst it's in the process. And so the contract was executed on the K2, on the proposal registry contract, transaction was completed. And so now it's going ahead to register you on the K2 contract. Similarly, you get a log when that completes on the execution layer. But I could show you that given transaction hash of the success 23 seconds ago on chain. And I believe when we add this when we add the K2, this should increase. And so the K2 registration transaction has been sent. We're just waiting for it to execute as well.
So we should see available to borrow for restaked ETH available to borrow will go up in the contract for people creating SPV positions.
Correct. Yeah.
Right. So it's pretty resilient, as we've seen. It does all the checks and will ensure that all the invalid keys are filtered out, and only the keys that can register. So one thing to bear in mind here is obviously if you're already in the registry, you cannot register again. You cannot double register, and if you leave the registries, then you cannot come back in with the same BLS keys. You have to basically create a new BLS credentials and rejoin the consensus layer. So it gives strong civil resistance. And at some point, so obviously in maybe some future videos, we can show how to deregister, right? This K2 module, Ronnie, if you could touch upon it, will have the features for claiming the earnings from the K2 protocol. And if you can undelegate, you can do all those kind of things, right?
Yeah, that's correct. So once registration is complete and with our representative address configured in the module, the K2 module would eventually expose a secured API by means of which you can perform Web3 contract interactions over your typical HTTP requests, and the module would handle that effectively using the right keys and the right registration messages configured on the contracts. And so this is typically how like the flow would be. We would have like your proposal registrations after all the checks running. The safety checks are quite thorough, even before the next set of registrations on the K2 contract. So if anything goes wrong, it fails through and doesn't causes is funds being moved, is assets being secured. So it fails through and doesn't ensure any erroneous activity goes on within the module, either by means of faulty messaging, which if you, of course, we had like the similar case where if you passed like a wrong BLS key or something was spoofed or wasn't correct, it validates this, and its fall through nature would not allow your registered funds or your validator keys to be moved either to like the registry or the K2 lending pool if there's something wrong with your node or with your node messaging. And so let's say
can we go to the dApp?
Yeah.
And see like the available tomorrow should have gone up.
So this is the K2 contract execution going through, and then the dApp was 3029. Just connect the wallet. And then now it's much higher now. So
so more SPVs can be created. That's super awesome.
Yeah.
So you can add hundreds of validators in one go.
Yeah, you can add tons of validators. So for any node runner that has thousands and thousands of keys, it would batch all of them. So in as much as we just did a few 7.
What's the gas limit? Is there any kind of numbers that you want to limit, like a one given?
I would say for like the effective use, we could come out with an effective number ideally you have to batch, but there's no like actual restraint at the moment to the number of keys. But of course, with a larger size, more computational cost, and so like a little bit.
Because a lot of big node runners have like 10,000 keys and 20,000 keys, right? So if you go to Lido, this kind of large staking pools have a lot of large number of keys, and if there is like all of them are coming in, then it's
the module will automatically manage that. It'll automatically manage like doing it in like over more than one transaction. So they don't have to think about it from their side.
Okay, that was my question.
Okay.
Do you really need to understand transactions, because there's always a gap for the transaction?
So the whole it's a whole new paradigm registering your validator credentials on chain. And from a node operator perspective, it's there's a big learning curve here. So the idea with the K2 native delegation module and MEV Plus in general, this sidecar ecosystem will take care of smart contract execution for you and manage all those things, regardless how many keys you're managing.
It's pretty different from how you register with them and maybe Relay, because they're just doing it like an off chain. But this is like do all the checks in off chain and in your secure enclave. air gap computer, whatever it is. And then you are communicating to the blockchain, and it's just going to replicate all the state, and it does all the validations. And then it also takes care of how many of them actually going to be parsed to that. Because you cannot just put like 10,000 things in a block, right? Because obviously there's a gas limit, there's other transactions are going through. We don't know which builder is going to pick it up, and then, but it will automatically manage all of that payload, transaction payload.
That's right, and existing relayers can actually, they can delete the registration databases that they have, because obviously running a relay is very costly and has huge overhead from a data perspective. So that can be completely deleted because so in the builder spec, in the builder API spec, there is an SSE container, a validator registration v1 that's has been propagated on chain, and all the relays can sync the proposer registry, so they can completely delete that, and they don't they can just use the on-chain source of truth. And if the validator's kicked from the consensus layer, it'll get kicked from the execution layer as well. So there's no management updates needed to take place, and you don't have to replicate it amongst multiple relayers. It's all taken care of here, complying with Ethereum specifications.
All right, so that's about the K2 native delegations, and now you can delegate $1 billion worth of ETH in one go, and then someone can borrow, 1 billion worth of ETH at a fraction of cost and tokens. The tokens, and start experimenting. That is, delegating is a few seconds or a few minutes, depends on the Ethereum blockchains. And minting and starting up your own RST network is also same, a few seconds or minutes until your transaction getting confirmed, and you're good to go.
Yep.
I think we're still sticking with a 60 seconds rule, but block confirmations need to come through, so that's the only thing.
Right, exactly.
All right. Thanks for walking through, and we'll see where it goes. We're going to open the testnet pretty soon. You can do the native delegation to the mainnet, or you can just do the proposal registration today, right?
Yes.
The proposer registration can be done on Ethereum. So that's the pre-registration step for native delegation. So that will be doable soon.
And you just run the same module, right? And look at the docs, and it will have information how to do the pre-registrations. If you want to get into the K2s and the testnets, finishing mainnet is coming up. You can be there, because there will be a queue to get into the native delegation on the K2, because it will only allow certain limits of the validators. Even though you're there, there are ceilings, just to make sure that the diversity of the nodes can be enabled for the native delegation. All right, cool. Thank you.
Thanks, guys. Let's see your SPPs, your RSTs, and let's do it.
All right, cool. Bye.